Hello everyone, my name is Gopikiran and in this video I am going to explain my complete RAG based AI chatbot system and that I built using AWS Bedrock or Pinecone LangGraph and DynamoDB and Streamlit. Okay, so in this project demonstrate how we to build a production ready chatbot that can be store multiple conversations and retrieve information from the documents and generate the accurate answers using Amazon Login. So in this video I will explain the overall architecture and backend files and front-end Streamlit files and how the chatbot retrieve documents and how conversation history is saved and a complete walkthrough of the code. Before going to the code, I will explain the project architecture overview. So my system contains 5 main components. One is AWS Bedrock Nova Pro. This is the LLM that generate answers, and Titan embeddings, so converts text and documents into a vector embeddings, and Pinecone Vector Database, and this stores the all documents and helps the retrieve the most relevant ones. And next one is DynamoDB, stores all conversation history using LangGraph checkpoints. So and next one, final one is the Streamlit UI, so provides a simple clean chat interfaces. Whenever the user asks a questions, the question goes to the backend workflow embedding and generated Pinecone retrievers and relevant documents. A RAG prompt is prepared, a Bedrock creates the final answer, and the chat is saved in a DynamoDB, and Streamlit displays the response. So this creates the complete end-to-end RAG chatbot. So this is also like based on a RAG architecture. So we all know previous one in the video we can know the RAG chatbot on RAG architecture. Now I will explain how the backend works. So I have to load the all requirement libraries. This file begins by the importing important libraries like LangGraph or Bedrock, Embeddings or Pinecone or DynamoDB, and Python utilities like environment variables or HTTP requests. So these imports create the foundations for building the graph workflow and generating embeddings and sending prompts to Bedrock and retrieving documents, saving conversation history. So everything in the backend builds using these modules. Now we have to set up the AWS Bedrock. So this file loads the environment variables and connects the AWS Bedrock using the Moto3 library. Then it loads the Amazon Nova Pro LLM, which is a high quality model for generating answers, or it is also loads the Titan embedding models, which converts the text into a vector form. So this means the backend now understand the both how to generate answers and how to embed the stores the documents. So designing the RAG prompt templates. So in this file I wrote the strict prompt templates that instructed the model to only use retrieved documents, not assume anything, not hallucinate. So gives the accurate or supported answers, clearly say it information is missing. So this ensures every response is reliable and trustworthy. Next I go to the connection to the Pinecone. So next the system connects the Pinecone using the API key and loads the existing index. So using the Titan embeddings, the vector stores is created and retriever is prepared. So the retriever fetches the top 10 most relevant documents for each query. So this means whenever the user asks a question, the system fetches the Pinecone, finds the most relevant text or sends the text to the LLM along with the prompt like. So next I have to go to the messages state. So defining the message state, I created a message state class that defines how messages are stored in a LangGraph. Okay, this structure lets the system keep track all the messages in the conversion, so including both human and AI messages. So next I have to create the I have to create the main chat LLM function. So this is the heart of the backend. So when the user sends a messages, here the system can retrieve relevant documents from Pinecone. So all formats or documents into a one string. So this file the rack prompts templates and it sends the prompt to a Bedrock, or it returns the generating a response. So this step ensures that everyone response is always connected with retrieved documents, or making it of a proper rack system. Yeah, next I have to build the LangGraph workflow. So I used the LangGraph to build a simple workflow. So it is start, which is first one is start, and middle one is the chat LLM, and second one is end. So this workflow execute every time a message arrives. So I also connected the DynamoDB server so that everyone message is stored in a DynamoDB, so as a checkpoint. So this allows the full conversation memory or ability to resume old chats or multiple chat threads. So this completes the backend architecture. Now I will explain the Streamlit UI files. This files controls how the user interacts with the chatbot. Now let's go with the starting imported UI and workflow tools. I imported LangGraph for workflow and Streamlit and messages types and bot tree, and which is a SDK from AWS to run this, and UAID, which is to the thread ID to give the chat, and this prepares the systems to communicate with the backend workflow and display messages, and manage sections talk to the dynamic DB. Next we are going with starting method, which is generating chat thread IDs. Every chat conversations has a unique thread ID, creating using UID. So this allows user to switch between conversations like ChatGPT. For example, thread 1 HR queries, and thread 2 project questions, and thread 3 company policies. Each thread has a stored separately. Next we have to reset chat functions. So when the user clicks new chat, the system creates a new thread and reset messages history and saves the new thread to Streamlit sections. Here we are going to do this. So okay, this makes the UI behaves like a professional chat application. Now we have to load the conversations functions. So this function fetches the chat history from the DynamoDB database using LangGraph workflow state. So when the user returns the thread, it loads all past messages, restores the full conversation. This gives persistent conversation memory. Now we have to get the all thread IDs from the dynamic DB, so we can use the user. So this part scans the whole dynamic database table, so that covers all chat IDs. So even if the server restarts, all conversations are preserved. So this is the functions of all conversation messages that for a specific thread ID. So conversation thread ID, so configure try exceptions. So this workflow statement configure values and messages given the different thread IDs. Now we are going to extract the content or text utility. So this function cleans the messages content, since LLM returns message in a different formats. So this function converts everything into a plain text or display. So in this text content we have instance content and the string. Only text can be user can get the only plain text. Now we have to setting Streamlit section states. So I initialize this Streamlit section state. So one is the messages tree, and the second one is the thread ID, and third one is the chat threads. So this ensures a consistent UI experience even if the page reloads. Now I have to go the sidebars in the display section. So in the sidebar I display the company logo, so I show a new chat button, so I list all the previous conversations. Clicking the conversation loads the full chat from the dynamic DB. Now I have to, in this method I have to rendering the chat messages. So I loop through the messages tree and use the Streamlit chat messages components to display them in the user assistant style. So this is the method to the rendering the chat messages. This creates a simple and a clean chatbot UI. So UI means user interface, so user can use freely. Next I have to grow the handling user input. So I have to take in the input from the user. So when the user types a question, it displays immediately. And added the section history. The backend workflow is called with the thread ID. So AI responses streamed and shown the assistant messages is saved to history. Then this method gives the real-time chat experience just like the ChatGPT. So here I can show you how we can write the front-end Streamlit file. So we have to create the virtual environment and activate that virtual environment. So next we are going to type the Streamlit run and file name.py. So whatever the file name you have to give into the file name. So after we can run the Streamlit run command. So the terminal run the command and gives the server links. So its server links directly takes to the Chrome, which is the default app of in your server, so in your laptop, so which is your default app or Microsoft Edge or Chrome, so it taken to that app. This is the guys interface of our RAG chatbot. So here after running this code in the terminal, so the server open in your default browser. So after opening it looks like a ChatGPT of user interface. Like here we can get the sidebar system here, new chat, it takes to the new chat, and here in my conversations I have a previous thread IDs like previous chat history, so user can get the chat history from previous ones after chat history saved in the checkpointers like given in the file. So here we can get the user chatting section, so user can give the whatever he want, gives the message to, this message is taken as the input to the LLM and gives the response in the plain text.